Salts are ionic compounds formed from the neutralization of acids. Acids, when they're neutralized, they give out their hydrogen, they lose a hydrogen, and that hydrogen gets replaced with a positive ion, usually from a metal or ammonium. There are different methods for making salts, and the methods that you use depends on the solubility of both the products and the reactants. The different solubilities of salts is something you need to memorize for your exam. I'll just put them up on the screen now, but you need to be able to remember these. I find it easier to break them down into groups. Rather than trying to remember every single salt, just remember the following rules. It still is a little bit of memorization, unfortunately. There's no trick to it. Every salt that contains an element from group 1, so sodium, potassium, salts, are always soluble. Always. There are no exceptions. So every salt which contains an element from group 1 is soluble. Every salt that contains the ammonium ion is soluble. No exceptions again. Okay. Every salt that contains a nitrate is soluble. So far we've got a bunch of rules where there are no exceptions. Anything from group 1, ammonium, nitrates, all soluble. So just remember those as a bunch. The soluble salts are group 1, ammonium, and nitrates. If you have a salt that contains a chloride, they are soluble, but there are two exceptions. Lead chloride and silver chloride are not soluble. They are insoluble. So now we're getting our first exceptions. All chlorides are soluble except lead and silver. Sulfates, anything that contains the sulfate ion, is soluble, except this time there are three exceptions: barium, lead, and calcium. You just have to remember this, there's no trick to it. Now we look at the insoluble ones. Carbonates are insoluble. Anything that contains the carbonate ion is insoluble. But we remember our rules from before, not if they have something from group 1 or ammonia. So carbonates are insoluble, but potassium carbonate, sodium carbonate, ammonium carbonate, they're all soluble, because that's our first rule from earlier. Hydroxides are insoluble, again, except for the rules that we had before: sodium, potassium, ammonium. And one more rule if it is a calcium hydroxide. Calcium hydroxide is very slightly soluble. So here's the rules. Everything from group 1 and ammonium, always soluble. Nitrates, always soluble. Chlorides, always soluble except for two, lead and silver. Sulfates, always soluble except for barium, calcium, and lead. Carbonates, always insoluble except for the rules we've already established. Hydroxides, always insoluble except for the rules we've already established. So if you break it down like that, it's not that much to remember, but you do have to remember a little part of it. Okay, so now we know which salts are soluble and which salts are insoluble. We can use that to determine the method for making the salt. And you will usually be asked to make clean, dry, pure crystals of a salt. Okay? There are three methods depending on the solubility or insolubility of the products and the reactants. So the first one that you would make is where everything is soluble, where you're making a soluble salt, so a salt that dissolves in water, from two soluble reactants, so an alkali and an acid. You would have to do titration. So the steps are: carry out a titration to determine the end point. Repeat the titration, but without the indicator. Take your titrant, the stuff that you've got, your neutralized salt, at this point it will be neutralized acid and alkali, it's made water and salt. Then if you've done it correctly, that should be a solution of pure salt, down to the drop, with water. Now you just got to get rid of that water. You do that by heating it. You heat it in an evaporating basin, but you don't heat it until it's dry. The reason you don't heat it until it's dry is because it won't form crystals. It will form a powder. So you heat it up until, and the key word for the exam is crystallization point or saturation point. They mean the same thing. Once you've done that, you allow it to cool, and crystals will form. So let's just repeat the steps. Titrate to find the end point. Repeat the titration without the indicator. Heat the titrant, heat the solution to saturation point, allow it to cool. So that's what you do if you're making a soluble salt from soluble reactants. Okay? You might in the exam get told that it's soluble, or you might have to use the rules from earlier to figure out that it's soluble. Okay? The next one is where you're making a soluble salt, so your product's going to be soluble, from something insoluble. So that might be a lump of metal. That might be a lump of carbonate, like a rock. Okay? Salts, you're always reacting with acids. Acids are always soluble. Okay? So only one of our reactants is going to be insoluble. So what you have to do is you've got to fully react all of your acid. And you do that by adding an excess of your insoluble thing. So for example, if it's calcium carbonate, you'll keep adding calcium carbonate until it stops bubbling. So step one, add an excess of your metal or carbonate to acid until it stops reacting. Then you've got to get rid of that excess. So the next step is to filter. Filter to remove the unreacted carbonate or metal. Third step, you take the filtrate, that's the liquid, and you heat it up. Heat it up to crystallization point and allow it to cool. Same steps. So that is making a soluble salt, one that dissolves in water, from an insoluble base or metal and an acid. The third type is where the salt that you're making is going to be insoluble. So that might be from our list earlier of insoluble salts. Okay? A carbonate or a hydroxide. And this time, you're going to get a precipitate. You're going to make a precipitate. Precipitate is what you get when you make a solid from liquids. So you mix together your two reactants, your acid and your alkali. You mix those together. You'll form a solid. So step one, mix together to form a precipitate. Step two, filter out the precipitate. The difference here is that you now take the solid, not the liquid. The third step is different. You have to wash the precipitate with water. This is where a lot of students get this wrong. You can only wash an insoluble salt. If you try to wash a soluble salt, you'll dissolve it. It'll go away. Okay? Wash it to remove any impurities. Then you heat it up, and it's dry. You can heat it up in an oven, or just put it on a windowsill and allow it to dry. And that is your insoluble salt. So to recap that last one, to make an insoluble salt from soluble reactants, mix them together to form a precipitate, filter out the precipitate, wash the precipitate, dry the precipitate. That's often 4 separate marks. Okay, so here are the different steps for the 3 different methods. Again, it depends on what you are making and what you are making it from. Okay, that's salts and solubility. Thanks for watching.